almost made that last video way too long, so that's why I cut it off. So our third type of question here is if sine of theta equals 5 over 13 and theta lies in quadrant 2, find the exact value of cosine 2 theta. So it's a little bit different than probably where you thought this was going to go. Way back when in an old lesson we did problems very similar to this. I gave you sine and the quadrant it lied in, you sketched it out, and you found like cosine or tangent or whatever. But now they're asking you to find cosine of 2 theta. So let's see how this is going to work out. The first thing that we need to do is go ahead and just sketch out this angle in a coordinate grid. So we know it lies in quadrant 2, right here. And we need to draw our terminal side. We can then create a triangle from the x-axis up to our terminal side. Remember, you would never draw it to the y-axis. It would look like this. And now our theta is going to be right here. This is our reference angle. So this angle and this angle are going to have the same ratio. So sine of theta is 5 over 13, and that's for opposite over hypotenuse. So I'm going to write those values in, 5 here, 13 here. We don't know this x value. We don't know that side of the triangle, so we need to find it. Hopefully you remember to find a missing side of a right triangle, you just quickly do Pythagorean theorem. You may even recognize this as a special triangle, a Pythagorean triplet. But if you don't, that's okay. You can still do the math. And what I'm doing here is just solving the equation, and so x equals 12. If you need to pause for a moment and digest what I have here, that's fine. But I'm going to go ahead and move on. So my x value is 12. So how on earth do we find cosine of 2 theta? Well, there's a couple different ways. You can use any of these formulas on the right. So you could use one that needs cosine and sine. You could also use the formula that just needs cosine, and you could also use the formula that just needs sine. So even though we did this work and we found this adjacent side here, we can actually solve the problem without using that information. We can solve the problem with just what's given, because we're given sine and there's a formula that only needs sine. So here we go. Let's write out that identity. Cosine of 2 theta equals 1 minus 2 sine squared theta. Since we know sine squared theta, we can plug that in. It's equal to 5 over 13. And since it's sine squared, we need to square the 5 over 13. So what I'm doing here is just substituting. I know sine of theta equals 5 over 13. So sine of theta equals 5 over 13. Substituting. So now we just work through that, and we get 1 minus 2 over 1 times 25 over 169. Holy moly. And then we're going to have 1 minus 50 over 169. And in order to subtract those, we need to get common denominators. So we've got 169 over 169 minus 50 over 169. And the final answer is 119 over 169. So this is equal to this. Now, keep in mind that since we were able to find the adjacent side, we could have used any 3 of these formulas. We could have used cosine and plugged it in and used the second formula, or we could have plugged in both cosine and sine. However, whenever you're solving these problems, want to take the path of least resistance. So We could have just simply started doing this work without sketching our coordinate grid, without looking at the angle whatsoever. So that'll come with practice, but I wanted you to see that we could have done it with any of the formulas. So your warm-up problem is going to be, I always have trouble with this, I always forget about it. I'm going to pull it out of the book. So the warm-up problem I want you to do is on page 585. And 585. And I want you to do number 9C. So 9C. And you'll see what I mean whenever you look at it. Go ahead and try that. Good luck. And tomorrow we'll go over it and see how you did.